So I'm going to be solving to this question on, it's not to this question, I'm going to be solving the question on climbing stairs. Okay, so the question says that you are climbing a stairs and it takes n steps to reach the top. Each time you either climb one or two steps. In how many distinct ways can you climb to the top? How many ways can you climb to the top? Okay, so n will be the number of steps. So in this example one, n is the number of steps and it takes two steps. So how many ways can you get to the top? So if n is 2, there are two ways to climb to the top. Is either you take one step or you just take two steps. If n was 3, there will be 3 ways. Is either you take one step, or you take one step, then two steps, or you take two steps, then one step. Okay, so basically, the question is stating that you have n steps and you want to know how many ways can you get to the top. So for example, if you have two steps, right, you want to know if you have two steps, step 1 and step 2, how many ways can you get to the top? I can decide to go from here and take one step and then one step. That's one way. So one way reaches us to one step plus one step, or I can just go two steps straight. The question says that you can only go one step or two steps. So if I go two steps straight out, that's another way. Go two steps straight. So there are two ways in total. So this plus this will be two steps in total. So how about if we are given 100 steps? How can I find it? Well, we can. So 100 steps, that's steps plus. Okay, so instead of 100 steps, let's go 10 steps. 10 plus steps plus another step plus another step. On 10 steps. So I can decide to go 1, 1, 1, 1, 1, 1, 1 to 10. That's 1. I can decide to go 1 first, then 2, or 1, 1, 1. Then when I get to the 8th step, I go 2. That's another way. I can decide to go 1, then 2, then 1, then 2. I can even decide to go 2, then another 2, then another 2 to the 10th step. So how do we solve this? Now let's think about it for a second. We can actually solve this using dynamic programming, and I'm saying we can solve this using dynamic programming because I've solved it before, but I just want us to think about it well, right? So the way we think about it is, instead of going straight to 10, or instead of going straight to 10, right, we can build up basically. So how do we build up? Let's say we have one step. How many ways can you climb it? Only one way, right? You only take one step. If we have two steps, how many ways can we climb it? We either climb it by taking one step, or we climb it by taking two steps. So I'm just going to have a value here. So if your step is 1, you have 1, you take one step. If your step is 2, you go 2 ways. How about if we have 3? If we have 3, we can decide to take 1, 2, 3. That's 1. Take 2, then 1. That's 2. Then take 1, then that's 3. Follow me, please. If we are having 4 steps, we can decide to take 1, 1, 1, 1, or take 2, 1, 1, or take. So we can go 1, 1, 1, 1. That's one way. We can take 2 first round, then go 1, 1. That's another way. We can take 2 and then 2 again. That's 3 ways. We can go 1, then take 2, then 1. That's another way. What I'm trying to get by is that there's actually a sub problem, and this is what I mean. You notice that the amount of ways you can get to 4 is actually the amount of ways. Okay, so what we'll be doing is we're going to just focus on the 4th step, this last step. To get to this last step, we can either get to this last step by coming from 2 ways. We can get to this 4th step by coming from the 3rd step or the 2nd step. Let's take that again. Let's look at it from a perspective of maybe 6 steps, right? 1, 2, 3, 4, 5, 6. How many ways can you get to this 6th step? How many ways can you get to this 6th step when you can either take one step or two steps? So let's just focus on this sixth step. For us to get to this sixth step, is either we come directly from the fifth step. Is that we come directly from the sixth step. That means we take one step from the sixth step, or we take 2 steps from the fifth step. So we have two choices: go from the fourth step or go from the fifth step. Meaning that in order to get to the sixth step, it is an addition of the amount of ways in which we get to the fourth, the addition of the amount of ways which we get to the fourth step, plus the amount of ways in which we get to this fifth step. So if we get to the fourth step in maybe 5 ways, and then we get to the fifth step in maybe 7 ways, the amount of ways to get to the sixth step is coming from the 4 ways plus coming from the fifth, from getting to the fourth step plus coming from getting to the fifth step. That's what I'm just trying to explain. So basically I'm trying to explain. So from this I can actually see a sub problem. I can see that in order for me to actually get to the sixth step, it is dependent on me getting to the fourth step, to 2 step, either getting from the step behind it, or getting from this, either get from the step behind it, or getting from the step 2 step behind it, right? So back to this subsequence, meaning that for me to get to this third step is either I come from the second step or I come from the fourth step. So it's an addition of coming from the second step and coming from the fourth step, which is 1 plus 2, which is 3. So for me to get to the fourth step is an addition of me coming from the second step and me coming from the third step, which is 5. For me to get to the fifth step is an addition of me coming from the third step and for me coming from the fourth step, which is 3 plus 5, which is 8. So basically, our subsequence is for me to get, let's do function, for me to get to the n step, it is actually equals to me coming from the n minus 1 step plus coming from the n minus 2 step. That is what will give me the n step. So from this now I can build up. This is a bottom up approach. So I'm going from the bottom to the top. We're going from the base case up. So if it's 1 is 1 way, if there are 2 steps is 2 ways, if there are 3 steps is a combination of coming from the second step and the first step. Therefore they are coming from 3 to 2. So with this now I can write my code, right? So when I'm writing my code, I'm going to start by creating my base case. So I'm going to say that I can just call it a variable called dp equals to an array, and in the array I'm going to have an array of 1 and 2. So of 1 and 2, because of 1 will be the array, one will be the array of 1 step, that's just 1 step. 2 will be the array of the second step, right? So for me to now get the rest of the n step, I'm going to be looping, right? So I'm going to be looking from, let's call it I in the range of n, right? But I'm going to be starting from 3, basically. I'm going to be starting from, should I start from 3 or 2? I should start from 2 because of this is a 0 index. This is 0, 1. Or better still, I think I'll just put, so that I don't confuse myself, I'll start from 0, 1, 2, so that just to offset it. So the next one would be 3, right? So I'm going to start my range from 3 to n. And what I'll be doing is in the for loop, right? I'll be doing dp dot append, right? I'll be appending to the dp, but what I'll be appending is I'll be appending the result of the previous one, which is I'm getting I-1 plus the result of the previous. which is I minus 2. So this will give me the next one, and then I'll keep appending until I get to n. Actually, I'll keep appending until I get to n, n plus 1, and then I'll just return dp of the last index. I'll be using n plus 1 because of in Python, when you range to n, it gives you n minus 1. So if you do range of 1 to 5, it will actually give you 1, 2, 3, 4, and it will give you the value 5. So I can try that, right? So I said I was going to do dp. I set it to 0, 1, 2, and then I was going to do for I in range of from 3 to n plus 1. And what I'll be doing dp for append, and then I'll be appending the addition of or just addition of the last two index. So dp of times 2, and then I will just return the last index. But I'm just going to say this, if n is less than 3, I think I can just return n. So if n is less than 3, if n is 2, the answer is 2. If n is 1, the answer is 1. If n is 0, the answer is 0. So I can just return this, and then I can run the code. And it passes for the test cases, for the first test cases, for these two test cases, and it works. Cool. That is one way, right? So this method of solving it is called bottom up, but there's another way of solving this kind of question, and it's called a top-down approach. And the top-down approach uses recursion, actually. So a top-down approach, and how this works is, okay, so we have a stairs, right? And we want to count how many times you can reach this top by either taking a step or taking 2 steps. So we can do a top-down approach by actually just finding all the possible ways and counting them. So when I mean counting all the possible ways, is what I'm trying to say is just go wild, count 1 1 1 1 1, count 1 1 1 1 2, count 1 1 1 1 3, count 1 1, jump 1, just count all this. So basically what I'm trying to say is that okay, at the first index, I either want to move to the next step or I want to go twice to the next step. So this will be a decision tree, right? At this index. So now I'm on this index. I want to go. So I start from like index 0 from the base. So I either want to go to the first index or I want to go to the second index. When I'm at this index, I either want to go to the next index or I want to go 2 times 3. When I'm at this point, I either want to go 3 or I want to go 2 plus 2, 4. When I'm at this point, I want to go 3 or I want to go 4. When I'm at this point, I want to go 4 or I want to go, how many times do I want to go here? I want to go 5, Alright, so basically this is what I want to do. I want to go wild. Let's actually use it to solve. Let's use it to solve a question, right? Let's say n was 4. And remember, I think we solved for 4. 4 should actually give us 5. So what we want to do is that at first we don't want to be on any stairs. So we want to go wild. We want to say, we want to take the first step. We want to go to the first step at first, or we want to go to the second step. Then at the first step, what do we want to do? We want to go to the next step, 2, or we want to go 2 plus 1, 3. So this time we're taking 1 step, we're taking 2 steps, we're taking 1 step, we're taking 2 steps. Yeah, we're taking 1 step, we're taking 2 steps. Yeah, we're taking 1 step, we're taking 2 steps. Here we're taking one step. We're taking two steps, but we cannot take two steps here because if we take two steps, we'll end up at 5. We are going to fall off basically because n, the number of steps is 4. At this point, we take one step. We can take two steps, right? At this point, we take what? We don't take any steps. So how many ways can you get there? You can go through this path, which is one way, or we can go through this path, which is 2 ways, or we can go through this path, which is 3 ways, or we can go through this path, which is 4 ways, or we can go through this path, which is 5 ways, right? So we actually end up with 5, right? Yeah, 5 ways. This is all good, but the disadvantage of this is that the time complexity is bad because of we're doing a decision tree. We're in every branch we're going 2 ways. So the time complexity will be 2 to the power of n, if I'm correct. Yeah, I'm not sure. 2 to the power of n because of at every point we're deciding we're going 2 ways. We're either going left or right. So we're going 2 ways at every point, 2 ways at every point, 2 ways at every point, right? Unlike the previous bottom down complexity, which is O of n because of we're just looping through n, right? And anytime we loop through n, we're just checking the last 2 values and adding it. Right? This is to the power of n. But there's something we can do that could improve this complexity, and that is what we call memoization. Memoization also. Yeah. It's called memoization, and how that works is, if you notice, we're kind of doing repeated work. Let's go through this branch. Okay, I think I should just write it. 0, 1, 2, 2, 3, 3, 4, 4, 3, 4, and 4. We're kind of doing repeated work because of when we go 1 or 2, right? Then we go 2 or 3, then we go 3 or 4, right? Then we go from 3, you can go to 4, Abby. Yeah, sorry. I think I didn't finish this. This will actually go to 4. Yeah, from 3 you can go to 4, right? So let's say we go like this. We're going there from year to year, then we go from year to year, then we go from year to year, then we go from year to year. At this point, we've gotten 1 way. Then we continue here, right? At this point, we've gotten 1 way. Then as we're about to continue here, we actually are going to do repeated work because of when we're continuing here, we've actually done all the possible way from theory. So we really do not need to start moving through this array, through this decision again, because of we know we've done it before. So what I'll be doing is that anytime I do a decision, the results from it, I'm going to store it in a cache, right? So that when I get to other part of the tree, instead of me to redo that decision, I don't do it because I already know what that competition will give me, right? Look at it again. When we come back here, this decision tree, we have to do it again. But we've actually done this decision tree here. This is the decision tree here. We want to redo the decision tree. Why do we need to do decision tree when we can actually save the value we get from this decision tree? So instead of doing this decision tree, we know what we get. So we just return it straight up. So that is, in that situation now, we don't do so much again. We reduce the time complexity. So much work. How do we actually complete this? So how we complete this is going to be kind of similar. We're doing recursion, right? So I'm going to have a function called recursion, and this is going to take our current index, and what this index will do is going to call a function of I plus 1, and it's going to add it to calling a function of I plus 2, right? So basically what I'm doing is I'm going here and I'm going here. I want to add the result this is going to give me and add the result this is going to give me. So in my base case, what I'll be doing is that if I is greater than n, for example now, let's say when you get to 4, you want to go again. You can't go again. or when you get to 3 you want to go 2 step and go to 5, you cannot go to 5. So if I is greater than n, we want to return 0, meaning that you're not counting it. But I'm sorry, but this part should come here. If I is equals to n, it means that we've actually gotten to 4, we've gotten to the last step, so then we want to return 1, meaning that we've gotten to the last step, this is a 1, return it. So this will end up returning 1, which would eventually be returned here. This will return 1, and 1 plus 1 is 2, so that means from point 2 you can move 2 ways, which will eventually return. So we can code that one up too. So what we're doing is we're going to do something called create a function called because having an I. If I is greater than n, we want to say that we want to return 0. But if I is equals to n, it's good, we want to return 1, and then we actually want to go to I plus 1, and we want to add it to going to I plus 2, and whatever result we get, we want to return it to. And then what we want to do is we want to call the value because we want to call it on 0. So that we go 0, then 1, then 2, then 3, then 4, and then we return the answer. Return the answer of this. Okay, so if you notice, I'm not caching, right? This is going to give me the 2 to the power of n complexity. So if I submit this, I should get a timeout course. I should get a time limit exceeded. So time limit exceeded because of it keeps going, it keeps branching out, doing repeated work. So instead of me doing the repeated work, I'm going to create a cache outside. And what I'll do is I will check the cache first of all. But before I check the cache, I'll be storing in the cache first. Let's go accordingly. So I'm going to store whatever the value of I gives me. I'm going to store it. Whatever the value of I gives me, I'm going to store it inside the cache. And the first thing I'll do when I get there is I'm going to say, is I in this cache? Have I completed this before? If I've completed it before, no need to complete again. Just return the value of what is in the cache. Just return what is in the cache. So now I'm storing in the cache, and then I'm checking and returning the value in the cache. So if I submit this now, it works. So yeah, so this is actually like an easy dynamic programming question. It's kind of like the beginning. Yeah. So, all right, this makes sense.